starting here, and then we'll finish these ones up, and then we'll move on to as much of the next stuff as we can. Okay, here. Alright, so it's a lot more of the same. We're going to find the equation tangent line to the graph and f at the given point. We're going to use our, what should we call it, our new little formula that we've got. Okay, so it's just more of the same kind of practice. But notice the instructions changed on us a little bit, right? Here we were only finding the slope. On this one, we are finding the equation. Okay, so I'm going to ask you this question almost daily for the whole rest of the year. What two things do we need to find an equation of a tangent line? Slope and a point. And we talked about how yesterday our equation of a tangent line is going to be the point slope form. If you do not have that written down anywhere, that's what you need to write that down. That equation is memorized. Okay? We don't simplify that equation. We no longer do y equals mx plus b. Okay? That is dead to us. Okay? This is the equation we need. Okay. Right. Alright, so the limit as delta x approaches 0. It's okay for us to use the plug-in C method. Okay, not the one we did where we plugged in the x like this one here in example 3. Okay. Alright, so limit as delta x approaches 0. And I'm going to write out my with the C in it because again I'm trying to memorize it for the test on Friday. Okay. Alright, what are we going to plug in for the C? We're going to plug in the 5. So we've got f of 5 plus delta x minus f of 5 over delta x. Okay. Okay, so I am now going to plug this into this function that we've got. So we're following our instructions. So the instructions say, write the function, leave a blank for the x, put minus 1, right? And then I'm going to substitute in for my x, 5 plus delta x. And minus, I'm going to write the function again. This time it says we're substituting in a 5. This one we substitute in a 5. All over delta x. Alright, so let's see what we can do with our arithmetic here. Let's see what's 5 minus 1. 4. Okay, so we've got the limit as delta x approaches 0 of the square root of 4 plus delta x. Doesn't matter what order I do that in. Minus, what's 5 minus 1? 4. What's the square root of 4? Can I make that all the way to jump to there? Everybody okay with that? Make the calc, right? Subtraction plus square roots in your head, right? Alright. I'm not sure if this came up in any of the limits or any of the first week of homework. We're going to do what we call rationalizing the numerator. Okay, so rationalizing the denominator says multiply top and bottom by the radical, right? Remember last year sometimes, especially when we had the i's, we multiply by the conjugate. Okay, we're going to do the same thing here because our goal is we got to get this delta x out of the bottom. I can't have that down there because it's 0. So the only way to create movement in this problem and try to things around this to multiply by the conjugate of the numerator. That might be something that you want to write in words on the side somewhere, right? Multiply by the conjugate of the numerator. When it's called rationalizing the numerator. Sometimes what I say is more important than what I read. Plus delta x. So and the conjugate comes from this sign here in front of the 2, so plus 2. Our goal again is we're trying to get rid of the radical. We're trying to get that delta x to cancel out. Alright, I did not write so much. Okay, I'm going to keep my limit as delta x approaches 0. Okay, do I have to do all of FOIL? What do I do? First and last only. Good. So we've got the square root mass times the square root mass. I just get the jump at mean, right? So I just get 4 plus delta x. It's a square root times itself. It's the jump at mean. For my lasts, I get negative 2 times positive 2 is good. Now, we don't do things too quickly in calculus because we don't want to do more work than we need to. Our instinct says distribute that in, right? I'm not going to distribute it yet. I'm going to hold my horses and I'm going to wait and see if maybe I can get that cancel without distributing that message. If I distribute it in, I might just have to undistribute it, right? After factor it back out. Okay. What happens now in that new group? The force cancel. Okay, and then we've got the limit as delta. Alright. Just wait till, because I haven't done a lot of limit in BC yet this year, and they have a lot of limit in theirs, and I do it in theirs. Okay. Yeah, just basically, yeah. It's a good thing that I don't have to do it and take it because delta x square root of 4 plus delta x plus 2. Okay, and remember, multiplying by that conjugate is like multiplying by the number 1, right? We didn't change the problem in any way, we just moved it around. Okay, now what happens? The delta x is canceled, which is, that's the pattern. Hopefully you recognize it. That's the pattern we're looking for. We're looking to get rid of that delta x. Okay? What's left in the numerator? 1. And can I sub my 0 in at this point? Yeah. I'm not going to write it clean and pretty. I'm just going to sub in. So we've got 1 over, I can drop my limit because I'm subbing in my 0. 4 plus 0 plus 2, right? So we've got the square root of 4 is the square root of 4. 2 plus 2 is 1/4. Now, we did a lot of work to get the slope, right? This is what we calculated here is the slope. Have I answered what they wanted me to answer? No. No, I need to still write the equation of the tangent line. I got the slope. The point was given to us, right? All I have to do is plug into that formula right there. So I've got y minus, what's the y value? 2 equals, what's the slope? 1/4 times x minus 5. You don't need to simplify anymore, leave it like that. Okay? I don't want you to make a mistake doing the simplifying. Okay? So leave it like that. That is an equation of a line. We type that in Desmos, it will graph it for us. Type it into our calculators, we have to work. Okay. Alright. We'll try another one. Let's look at, so again, let's look at what the instructions are telling us. It's a similar problem, but not exactly the same. Okay. So they want the equation of the tangent line again. Okay. This time they give us an equation, and they say they want it to be parallel. What does it mean to be parallel? Okay, so we need to find the same slope, right? Okay, so I need to figure out the slope of this line right here. In order to do that, I got to get y by itself, right? So I'm going to move the y. I'm going to choose to add the y to both sides. It's going to give me y equals 3x minus 4. So what's the slope? 3. So I know that my slope is 3, but in order to write an equation of tangent line, what 2 things do I need? Okay, so I've got the slope. What am I missing? What point? So I'm going to have to use my new formula to find that point. Okay, and unfortunately this time we're going to. Oh wait, it's a cube. That was nice. We're going to have to do. We're going to leave the x's in it. Okay, so I'm going to write my formula instead of c's. I'm going to write it with x's. Right. So similar to that last example that we did yesterday. So example 3. Limit as delta x approaches 0 of f of x plus delta x, we find it derivative x, minus f of x all over delta x. Okay. Limit This says write the function and plug in x plus delta x, right? We're going to put parentheses cubed plus 2. Alright, so what am I substituting in there? X plus delta x. Okay. Minus, I'm going to take the function, so something cubed plus 2. What am I substituting into the function this time? X. So basically, I like to think of the back piece as write the function the way it looks, right? Basically, that's what it's about. Alright, and then we're all over delta x, right? Okay. I'm curious if I have. So I'm going to switch slides because this means we have to multiply it by itself 3 times. Okay? There are a number of ways that we can do it. Ignore these times. Okay, so we're not there yet. So that means I am doing this. I just need more space to do it. I can write it to make the switch on that screen. Okay? If you remember binomial expansion, that's probably the way I would do it. I had a kid who, the one that took like 21 AP tests, he would do it by binomial expansion every single time. Okay? Binomial expansion came in. Everybody else typically foiled and we had to get out the stupid box. Okay? So let's foil and get out the stupid box. Once we do this once, memorize what this looks like. Great. Okay? Or you refer back to it on this problem. Great. Alright, so what's x times x? X squared. X times delta x. X delta x, but I have how many of them? 2. So we get 2x delta x. And then delta x times delta x is delta x squared. So now I've got a trinomial times a binomial, right? That I can handle that it's not. Alright. So now we get out this stupid box. But it keeps our work organized. Got x squared plus 2x delta x plus delta x squared. And then x plus delta x. And I will tell you, if you haven't heard it before, it's never the calculus that's the issue in a problem. 95% of the time it's the algebra. Alright, so let's talk about this. X times x squared. X cubed. X times 2x delta x. Yeah. Delta x, good. X times delta x squared would be x delta x squared. Delta x times x squared would be x squared delta x. Delta x times 2x delta x, 2x delta x squared, good. And delta x times delta x squared would be delta x. And Mrs. Ballard's trick about the diagonals still works, right? There's rare chances that it doesn't, so don't always count on that, but it looks pretty good right now. Alright, so this is saying that we've got x cubed plus 3x squared delta x plus 3x delta x squared plus delta x cubed. Now, when we're doing this function, not let the algebra be the part that you're walking into. Okay? You've got to understand the calculus piece. Because am I going to give you a cube on Friday? Not likely, right? It's okay it's good to look at them. It's good to review, okay? And you're going to probably see one in the homework. That's probably why I'm doing it. But I wouldn't put that on an assessment. It takes too much algebra. Okay? I don't want the algebra to take away from the calculus and test you on the calculus. Alright, you guys remember the Pascal's triangle 1, 2, 1, 1, 3, 3, 1? Those are the coefficients right there, right? So we could have done the Pascal's triangle with the binomial expansions. Okay? Alright, so that's what we're going to put in. That's what I'm going to put in for this expansion right here, right? So I've got the limit. I've got the limit as delta x approaches 0 of x cubed plus 3x squared delta x rid of the delta x. That's our goal. Because if we put it in if we plug into 0, it gets 0 and it's undefined, and we can't have that, right? And we know better than that. That's not going to be undefined every time. All right, so let's look and see what we can cancel first. The x cubes go away. Okay, let 2's go away. You notice how every time they cancel, we get rid of everything that doesn't have a delta x. Okay, so that's a pattern you need to recognize. And remember that for the stop writing, right? Get rid of everything. You need to make sure everything except for the stuff with delta x is gone. Okay? That doesn't mean force it, right? You need to check to make sure your arithmetic's correct and your algebra's correct. Alright. It looks like I've got a delta x in all of them, right? What am I going to do with that delta x? Factor it out. Okay, so taking out the delta x, and I'm left with 3x squared plus 3x delta x plus delta x squared all over delta x. Alright, did we accomplish our goal? Delta x is what okay, I'm going to be lazy at this point. Can I go ahead and sub in my 0? Yeah, so the 3, now notice, what does the 0 get plugged in for? Not the x, right? The x is going to keep appear in our answer. 3x squared plus 3x times 0 plus 0 squared. It's going to happen with these two terms. Yes, so my answer is 3x squared. Now, let's make sure we answered the question. Okay? Did we find the equation of the tangent line? We found something that represents the slope, and we know the slope. What are we still missing? The point, right? So I'm going to take the slope that we calculated with the limit, and I'm going to set it equal to the slope that we calculated for the line, and I'm going to get my x values. How do I move the 3 over? Divide it, what do you get? 1, and then x. Ooh, I undo the square, that means I get, oh, there's 2 answers. Now, I've got the x value of the point. I need the y value. So how am I going to get the y value? Okay. Yeah, we got to plug back into this function here. This is like the never-ending problem. Okay. So I'm going to plug in and I'm going to leave some space in here and a gap in here on purpose. I'm going to plug in f1, so I get 1 cubed plus 2, which is going to be what? 3. Okay, and then I'm going to leave some space because I'm going to write my equation tangent line there. As of negative 1, I get negative 1 cubed plus 2, which is going to be 1. You see how the point popped out as 1, 3? The other point is negative 1, 1. I'm using that as my label for the line. Okay? So I'm going to go ahead and just use those points and then the slope of 3, right? So y minus my y value 3 equals my slope of 3x minus 1. Line number 3. Y minus my y value 1 equals my slope 3 times x minus the negative 1. That's about the only thing I would simplify as my double negative, and it's still not incorrect. Okay. How do I move on? Yeah, when you have to put the student boxes in the middle of it. Okay. Alright, so what I want to do is I want to move on to the next set of notes, right? That was finishing up yesterday's. So I want to keep going. I started class a little late yesterday, probably. Make sure to stay on track here, get this, so we can take a test on it Friday and move on to the next one. Okay. Alright, so you will need, once you've written the essential question, if you don't have a book at your spot, you're going to need a book. Okay? You're going to read a little bit more again. Not much, just one little spot. Books are up front. Again, write your essential question and then go grab a book. If you don't have a book, it also helps to stand up and get the blood flowing. Okay, so yesterday we focused on the tangent line side of the title. Today we're going to introduce what we call the derivative. They're pretty much the same thing. Okay, the derivative is the slope. We're going to read about that here in just a second. Okay, so all right. What I want you to do is take about 2 or 3 minutes, and I want you to read page 103 up to where it says example 3. You only can read through example 3. We'll do it together. Okay? So I want you to read page 103. I'm going to stop talking. Okay? It's not a bad idea to also read the little remarks on the sides, left-hand column, if you finish early. Okay? So we're going to take a couple minutes to read. Okay. There's a lot of actually really, are we still like we're done? Can we need another minute? Okay, one more minute. I read through. Okay. Good news is that the book that we got, the new book that we got, not the old book that had it, but this book is better than the old one. This one has more tidbits about AP in it than the old one did, even though the old one was an AP book. Okay? It says AP up at the top, right? And we got the thick one because the old one didn't have enough in it to do a BC course. That's why you got the thick one. We tried to get them to get the AP, the thin one, and the EC, the thick. Okay, going good. This one by the BC book. So, we got the thick. Um, so so the little insight there on the right on the left side when we get to looking at the notation, that's an important thing. Okay, so as you're looking through, if you're scanning through your book when you're doing your homework and you see any of those little things, it's not bad to read them. Okay, it's actually a good idea because it's giving you tidbits that are important for the AP test. I point out as many of them as I can throughout the year, but I might miss something. You never know. Okay. So you need to fill in some definitions for me, right? So there's your definitions or blanks. I don't know if you've got to fill in blanks or give you a couple minutes to do that. is in there for derivative, right? Derivative, I told you there's three big things we talk about. Limits, which is actually pretty tiny. Not that we're done with limits, but they're kind of a piece of what we're doing now. Okay? The differentiation or derivative or differentiable, they all kind of mean the same thing. That's one of our big processes that we have to learn here in calculus. It's one of the, if you split calculus into two, that's one of the big two. Okay? The differentiation is the limit. It's used to define the slope of the tangent line, also known as the process of finding the derivative. Okay? This thing right here. That right there. Derivative is the slope. Okay? On the morning of the AP test, we go out and we take a picture. And I ask you for the picture, what's the derivative? This is the answer right there. So there's the first question on the AP test day. Okay? Is what's the derivative? Okay? Then they give us some information about it being differentiable. It exists if it is differentiable on an open interval. If it's differentiable at every point in it. We're going to see some places eventually where it's not differentiable. Okay. Let's look at the... Okay, so then you have to fill in the definition of derivative, right? They have to fill that in, right? Fill in the formula. Isn't that the same formula we used yesterday? Only today we have X's in it, yesterday it had C's, right? So we're not memorizing anything new. Okay. The other thing that was in there was it said something about instantaneous rate of change. Somehow I accidentally have that in the third set of notes. Another thing we do with the derivatives, we find the rate of change. And it's really the rate of change at that instant, so they call it instantaneous rate of change. Sometimes they'll just say rate of change. You see the words rate of change, that relates to the slope, which relates to the derivative. Right, so they're all the same thing, the same process. Use this little thing. Okay. All right. Oh, there it is. Instantaneous rate of change. Okay, so here's the definition is flip a few pages. I don't know why I have it. I filled the wrong spot in the notes. If you flip to page 58, I've got a line for it there. Is it right under?
Yeah.
Oh, it is right under. Okay, I'm looking at the wrong page. Okay, never mind. Write it right under. I was looking at the front page. Apparently, it's in the ones for tomorrow too. I had it in one spot and I realized we didn't delete it. So it's basically the same as slope as the tangent line, right? So we calculate the slope, we calculate the instantaneous rate of change, or the rate of change, and we calculate the derivative. It's all the same calculation. Okay? All right, then they have a spot for the notation, right? Which was right in the book. So the first one is, did I go too fast? Alright, so the first one is, this one is one of the two most popular. Okay, so I'm going to write it, the more popular ones towards the left, and the less popular ones as we keep going, okay? And you notice that little insight thing said, it's important to make sure you understand all the different notations for it, because they're used interchangeably on the AP test. Remember how yesterday we read about Newton and Leibniz? They each were coming up with their own notations at the same time, and nobody made a distinction. Nobody made a, hey, this is the one we're going to use, so we use the one. Okay? Sometimes we use one over the other depending on what we're actually doing. Okay? This one we agreed, it's a notation for derivative. That's a little, it's kind of like a little slash, it's not a one. It's a prime symbol. Kind of like a single quote. Okay? If we read that as f prime of x, but it represents, it's a notation for the derivative. Okay? x. That's how we read it. Okay? This one here is the derivative of y with respect to x. That's what it means. We typically just say dy dx. Okay? But sometimes it's good to go back to that, the derivative of y with respect to x. You need to know what you're taking the derivative of, which is usually the x, and what variable it's with respect to, which would be the y. So that's the left. Usually the y is the left side of the equation. Yes. The derivative of y with respect, we would say to the derivative of x. No, derivative of y with respect to x. Yeah. I think it was that. Never read this. Okay. The next one, this one is probably would be third line. Sometimes you just write y prime. If you're in y notation instead of function notation, that's legitimate. Typically in y notation, they'll all go dy. Okay. All right. The other two are not seen as much. This one, every so often they'll give you instructions that look like this, which again means derivative of the function with respect to x. And then this last one you very rarely see, but it is still a possibility. I don't remember whose notation that was. So, yeah, I know. Okay. I'm not even sure how to read it. You don't use it every day. Okay. Alright, so those of you, but you need to know that they're all being derivative. Okay, or find the derivative or the notation. Once you've taken the derivative, if you started an F notation and you take the derivative, you have to rewrite your notation as the prime. Tell me that it's this derivative. Okay. Alright. Let's see if we get out. Oh, we'll get out in like 2 minutes, right? Okay, so I'm not going to start example 1. We'll start with example 1 tomorrow. Okay? I will get the homework posted right now. Okay, so we'll do the tangent line homework. Okay? And then tomorrow